Right. My name is Mark Kamal, and this is my presentation for Assessment Task 2 Cloud Security Project Design. This project was completed in collaboration with Abjah Mishra, and it focuses on designing secure and complement um, cloud architecture for a financial service organization using Amazon Web Services on the platform as a service model. The goal of this task was to ensure that the sensitive financial data remains protected, available, and complement, compl- compliant with Australian and international standards. As more financial institutions move their systems into cloud, they face more new challenges around data protection, compliance, and customer trust. Our job was to design a WS system, a WS-based architecture that would meet these needs, ensuring confidentiality, integrity, and availability of financial data. We followed the cloud security lifecycle, which allowed us to plan the security measures across every phase, from protection to detection to response and recovery. The design applies layered security using several AWS systems. We use IAM and Cognito for identity and access management, WAF and Shield for web and DOS protection, Guard Duty for threat detection, and Cloud Trial for auditing and monitoring. Our architecture aligns with the Privacy Act 1988, APRA, CPS 234, and PCI DSS, ensuring the system meets both technical and legal compliance standards for financial sector. To, to structure our design, we define three sets of requirements. Functional requirements like encryption, intrusion detection, multi-factor authentication, and access control. Non-functional requirements such as high availability, resilience, loss protection and monitoring, and regulatory requirements, which includes compliance with privacy and data protection laws. These guided every part of our design to make sure the solution we both was both secure and practical. So here's the architect we designed. It's a multi AZ environment divided into public and private subnets. The application tier is hosted using EC2 or App Runner with an elastic load balancer for distributing traffic. The database tier was Amazon RDS for secure multi-AZ data storage. Security services like WAF, Shield, Guard Duty, and Security Hub protect against external attacks, while Cloud Trial and CloudWatch handle monitoring and auditing. Finally, KMS manages encryption keys and IAM enforces least privilege access. Altogether, this design provides layered protection, scalability, and compliance. My main responsibilities were focused on security, networking, and access control. I designed the VPN structure with public and private subnets, created network access controls, and applied security groups to control and inbound and outbound traffic. I also configured the IAM and connector for authentication and MFA and used KMS and CloudTrial to ensure all data was encrypted and every user action was logged for auditing. One of the main challenges was selecting the right combination of AWS services since many overlap in functionality. Another challenge was managing IAM policies, which can become complex in larger environments. To overcome these, I researched AWS documentation, collaborated with my teammate, and tested configurations to ensure capability. For future improvements, we could automate deployments with CloudFormation and add mice and incident manager for stronger data protection and incident response. This project helped me gain hands-on experience with AWS cloud architecture and security compliance. I learned how to design practical solutions that align with the frameworks like NIST and APRA CPS 234 and how to document them professionally. It also strengthened my teamwork, research, and problem-solving skills while applying real-world security principles. In conclusion, this project has given me a deep understanding of how to design and present secure cloud architectures for financial organizations. It bridged the gap between theory and real-world implementation and gave me the confidence to design, complement, scalable, and resilient solutions using AWS. Thank you for listening.
Hello, everybody. My name is Abjad Mishra, and today I'll be talking about the solutions for the storage component within the AWS cloud-based systems as part of the storage, as part of the cloud-based security for the entire system as a whole. So the explanations will go on as follows. So basically, within the storage component of the AWS based systems, it can be explained as follows, in which it is mainly defined as as a service which helps provide for scalability, durability, integration with security features in such a way that it primarily emphasizes for encryption as well as the user logs and role-based sharings and so on as part of the as part of an entire database frame set, which would be like stored for security-based purposes within the AWS, along with being highly crucial in data protection, transit as well as transiting usage and so on, along with IAM policies helping to enforce the security as well as encryption, VPC integration, and so on. So that is how the component can be explained and understood in this scenario. And we move on to storage services, in which they can be grouped into three further components, such as the Amazon S3, as well as the Amazon EBS and the Amazon FSX. And they can be explained as follows, in which Amazon S3 is used for object storage along with unstructured data, such as transaction logs, customer records, and so on, along with accounting for durability, scalability, as well as being without a server and self-sufficient of versioning and various lifecycle policies. And for Amazon EBS, this generally points to blocking database storage, which is generally used in trading or core banking systems, as well as them utilizing high performance SSDs along with snapshot capabilities, multi-attach for higher availability. And Amazon FSX can generally be defined as a file storage system that is typically optimized for Windows banking apps or HPC computing for modeling risks, along with being utilized for Windows slash Linux file systems, along with integrating via an Active Directory. So this also explains for the further features within the storage services. And And we move on to the implementation based solutions, which is the core part of the topic here. So here's the step-by-step procedures of the implementation, which mainly involve four major steps, in which the first one is the IAM and the access controls, which technically involve ACLs being disabled, as well as them being able to cause unintended access. So in that case, one must switch to S3 object ownership with a bucket enforced setting, as well as them like being being done so to disable the ACLs, along with least privilege access being implemented by granting minimal permissions and using IAMs for workloads. And for the second step of bucket policies and public access controls, they are to be explained in a way that public access must be blocked by preventing accidental bucket exposures or objects to public internet, as well as enforcing secure bucket policies by denying insecure actions, along with further moving on to encryption, in which data encryption must be done to meet compliance as well as enforcing HTTPS TLS 1.2 plus by adding conditions to the bucket policies and monitoring with CloudWatch alarms on certain events where TLS is generally missing. And for the fourth and final step of networking isolation, come monitoring and auditing and incident response, it can be explained by implementing a VPC endpoints to keep traffic private within AWS by creating S3 gateway endpoint in the VPC console to then add a bucket policy to allow access as well as logging all requests to another bucket and logging all APC calls by using CloudWatch and setting alarms for spike numbers. So this is how the solution for security is to be implemented, especially for the storage component within the AWS cloud systems. Thank you.